Welcome back to eCraft. In our last video, we demonstrated how to read sensor data using the Arduino Uno, our 4 Wi-Fi board, and send it to a ThingSpeak channel. In this tutorial, we'll go beyond collecting IoT data and learn how to analyze it using ThingSpeak and MATLAB. If you missed our previous video, where we set up an IoT channel using ThingSpeak, I recommend checking that out first. The link is right there in the description box. It'll give you the foundation you need before diving into today's topic of creating MATLAB apps for analysis and visualization. In our ThingSpeak channel, the Arduino Uno, our 4 Wi-Fi board, collects air quality data from the SGP40 sensor, along with temperature and humidity readings from the BME280. These values are plotted as VOC Index, humidity, and temperature graphs. But once we have all this data, the big question is, what can we actually do with it? That's exactly what we'll explore in this video, turning raw sensor readings into meaningful analysis and interactive apps using MATLAB. Let's explore the apps that ThingSpeak offers. Broadly, there are two categories: analytics and actions. In this tutorial, we'll focus on the MATLAB Analysis and Visualization apps. These tools allow us to dig deeper into our IoT data, uncover patterns, and present insights in a way that's both interactive and easy to understand. You'll find a variety of ready-made examples to help you get started quickly. I've already created an app using one of these examples to display the high and low temperature values, which I'll show you in just a moment. And to make things even more interesting, I'll also walk you through building an app from scratch using one of the examples, so you'll see both the quick setup and the step-by-step process. If you want to read about these examples, there are help menus on the right. Now let's explore how we can apply an example MATLAB code to our channel. This analysis app calculates the high and low temperature values collected over the last 24 hours. If you're doing this for the first time, you'll notice that the default values, like the read channel ID, the read API key, and the field ID, are placeholders. To make the app work with our data, we simply replace these with our own channel parameters, which are conveniently displayed on the right side of the screen. The rest of the code is already provided for you. If you're comfortable with MATLAB, you'll see that it's a straightforward script. And if you're just starting out, don't worry. Like me, you'll find it easy to follow along and understand. Note that the results will appear in the output window. After making sure the channel-specific data are updated correctly, we will run the script. To run this script, just click on the Save and Run button. The results will instantly appear in the output window. What's even more useful is that this data can be written to another channel, and you can set up alarms or email notifications whenever the values cross certain preset thresholds. This way, your IoT system doesn't just collect data, it actively responds to it. We can clear the output window by clicking on the Clear Output button. Next, let's look at how we can analyze the average humidity data collected from our channel. This time, I'll walk you through the process right from the beginning. Using another MATLAB analysis example, we can calculate the mean humidity values over a chosen time period. Just like before, the default fields, such as channel ID, API key, and field ID, need to be updated with our own channel parameters. Here, I'm replacing the channel ID with the ID of this channel. The humidity data is stored in field number 2, so I'm selecting that as the field ID. Finally, I'm updating the read API key value to match our channel. With these changes in place, the script is now ready to process our actual data. Once that's done, by clicking on the Save and Run button enables the app processing the data and gives us a clear picture of the average humidity trend. This is a powerful way to move beyond raw readings and start uncovering meaningful insights from our IoT data. Notice that the humidity analysis has also been saved as an app within this channel. This means you can easily revisit it, rerun the script, or build on it later without starting from scratch. So far, we've been exploring the MATLAB analysis options. Now, let's switch gears and look at the visualization features. This part is even more interesting because it allows us to actually see the relationships in our data, whether it's visualizing the correlation between two parameters, generating histograms, or applying other powerful data-driven effects. With visualization, our IoT data comes alive and tells a story. Using one of the ThingSpeak examples, I've already created an app to visualize the correlation between temperature and humidity data. This script reads the values from their respective fields in the indoor air quality channel and generates a scatter plot. The plot makes it easy to see how temperature and humidity relate to each other, turning raw sensor readings into a clear visual story. This plot can also be added to the channel stats page. To do that, simply use the Add/Edit view on a channel option under the Display Settings window. That way, the visualization becomes part of your channel dashboard, making it easy to access and share alongside your other data. As we can see from the scatter plot, humidity and temperature show an inverse relationship. This visualization makes it easy to spot the trend and understand how these two parameters interact in our environment. In a similar way, we can also create a visualization for the VOC Index using a histogram. I've used the ThingSpeak example script, which reads the VOC data from our indoor air quality channel and then plots it as a histogram. This gives us a clear view of how the VOC values are distributed over time, showing not just individual readings, but the overall pattern of air quality. By adding this visualization to the channel stats page, we can quickly spot trends and understand how often certain VOC levels occur. Since the example MATLAB script was originally designed to plot a histogram of temperature data, we need to make a few adjustments to use it for the VOC index. Specifically, we'll update the variable names to point to the VOC field and change the axis labels so they correctly represent VOC values. With these simple edits, the script now generates a histogram that shows the distribution of VOC levels, giving us a clear picture of air quality patterns over time. We need to ensure that the channel ID, the field ID for reading the VOC index, which in this channel is field number 1, and the read API key are all entered properly. Once these parameters are updated, the script can access the right data and generate the histogram with accurate results. We also need to update the axis labels to match the data we're displaying. Since we're now working with VOC values, the label that originally showed temperature should be replaced with VOC Index or Air Quality Index. Once the script is ready, simply hit the Save and Run button, and the histogram appears in the output window, giving us a clear visualization of how VOC levels are distributed. To add the histogram to the channel dashboard, scroll down to the Display Settings section. From there, click on Add or Edit View on a channel, select Private View, and then hit the Save Display Settings button below. Once that's done, head back to the channel dashboard, and you'll see the VOC Index histogram neatly displayed alongside your other data visualizations. And that's how you can use ThingSpeak and MATLAB to turn IoT data into powerful analysis and interactive visualizations. If you enjoyed this tutorial, don't forget to like and subscribe to EECraft for more hands-on projects. In the next video, we'll take this even further, connecting our apps to smart alerts and automation. Thanks for watching. Stay tuned.